Without slides because why not? Okay. I'm sorry about that, but luckily they're mostly just words. So I'm here today to present on Saya, which is a decentralized cloud storage platform. And that's kind of a buzzword soup. So I wanted to break that down more. I think everybody has a different way of interpreting that. So what decentralized cloud storage platforms means to us, to break out the word decentralized, what we care about is actually the trust element. It's who controls the infrastructure, who controls the data, and what are the failure modes? Is there a single point of failure? Are there 50 points of failure? How many things have to go wrong before we lose whatever it is we're working with? And so when we say decentralized, what we mean is that there's no single point of failure. There's no single organization that can step in and do something malicious. And so we, by decentralized, mean that we've taken the power and spread the power out, which is a little bit different than distributed, which is what a lot of people mean when they say decentralized. So we take a very sharp line there. Secondly, when we say cloud storage, what we mean is taking your files and putting them into the cloud. You're storing bulk amounts of data without needing to have that data be local. And further, if it's in the cloud, it should be accessible from anywhere that's connected to the internet. So that's what we mean by cloud storage. And by platform, what we mean is that it's not necessarily like a Dropbox so much as it is like an AWS. We've built a piece of infrastructure that we want application developers and enterprises to leverage and to build on top of. And so we provide essentially a bunch of API endpoints, and then we provide sample applications that use these API endpoints. But the real intention is that other parties come in and develop on top of our platform. So we're doing an infrastructure play, and we're providing infrastructure to the rest of everyone. So we are an old project. We've been around since 2014. We released a white paper in 2014. It went through 2 iterations. First one was early 2014, and then we threw it out, started over, released a second white paper in November 2014. Believe it or not, that white paper today is largely an accurate description of how Saya works. So if you go and you read our 2014 November white paper, that is pretty close to how Saya works today. We're pretty proud of that. I think we're the only platform that hasn't thrown away our white paper in 2017 or 2018. So sorry about that. And if you want to see our white paper, you can go to saya.tech/saya.pdf or saya.tech/whitepaper.pdf. And the slide has a link in it, but yeah, you have to take my word for it. So in 2014, there were 4 major competitors, and they were all very well funded. We were like the small ones amongst the group. And yet, in 2015, we were the first to market. So we put a fully functioning, fully decentralized cloud storage platform out into the world June 2015. And of course, it was deficient in many ways, but it was more than a proof of concept because it didn't just show what it would do. It was, at the same time, fully decentralized on day one. We think this has been very important. In projects that we've seen that once you fall into the centralization trap, once you get used to those crutches that centralization gives you, certain things become so easy, and you can't walk away from them. I've yet to see a platform with some core part of the functionality be based on centralization and then be able to walk away from that. So we've been very careful since 2015. We will not leverage centralization at any point to add a feature because we're afraid that if we add that feature, we'll never be able to get away from that feature, and we'll be centralized for that piece forever. So we've done everything we can to stay away from that, and we have succeeded. So as I mentioned, our platform is targeted at application developers, both decentralized application developers and centralized application developers. And I think there's something to be said for even if Dropbox itself is centralized, and Dropbox is migrated, so perhaps not the best example, but if Dropbox were using the traditional cloud, Dropbox, the company, would be dependent on someone else. Dropbox has vital parts of their infrastructure that for a long time were dependent on AWS. So Dropbox managed to get away from this, at least in part, by using their own infrastructure. But rather than them having to go and learn how to build data storage infrastructure, what they could have done is switch to Saya. And even though to the end user of Dropbox, that's not, the end user is still centralized under Dropbox. Dropbox itself has a lot more independence and freedom, and really, Amazon today controls something like 50% of the web. If some of these companies start moving to decentralized backends like Saya, hopefully we can get that 50% number down. And so I definitely think that in the next year to year and a half, we're going to see a lot of centralized applications starting to move to decentralized backends. And while this isn't the full dream of every consumer application being decentralized, it's still a very important step. And it does make our society a more robust society. And that's very important. So that's something that we're trying to facilitate, especially in the early days. And then, of course, later on, we do want to see the fully decentralized Dropbox. We want to be able to get rid of all centralized control. But I think, one step at a time. So our platform today, just to cover some of the capabilities, we can provide storage for about $2 per terabyte per month. This can be contrasted to Amazon, which is about $21 per terabyte per month, last I checked. So we're 1/10 the cost. Scale, the platform scales pretty readily to about 3 terabytes per user. That would be per full node, right? So each full node today can go to about 3 terabytes stored. In the coming months, we have a big update coming out that we believe will push it to 20 to 30 terabytes. And then bandwidth. So bandwidth on AWS is anywhere from $50 per terabyte to download data if you are a bulk customer, to $90 a terabyte if you're a smaller customer. And bulk customer means tens of thousands of terabytes. Your AWS bills have to be millions of dollars before you start getting the bulk rates. On Saya, instead of $50, it's $1 to download 1 terabyte. So the bandwidth is incredibly competitive. And this is something that we think is going to be very useful to companies like Netflix or Reddit, who right now are stuck with these big centralized entity content distribution bills. So that's something that's in our sights and something that we hope to cater to. And then finally, the speeds on our network today are easily over 100 megabits per second upload and download. So as long as your home connection can keep up with that, we can saturate your home connection. And really, it's closer to 3 times that. So it's 300 megabits up, down that you can get on the Saya network today. So some of the existing applications that are building on Saya would be Pixel Drain, which is kind of like a mega upload sort of website. It's a centralized website that has all of its storage, all the files put onto Pixel Drain, backed up to Saya. Another big application is Goobox, which is they're aiming to actually be a decentralized Dropbox. And so they're cloud storage platform agnostic, but they'll readily acknowledge that Saya is the only fully decentralized cloud storage platform at this point. So we're happy to provide infrastructure to them. And then we have maybe half a dozen other applications to a dozen other applications that are in production or being actively developed by full-time teams that in some way or another are leveraging the Saya infrastructure. So I'm going to take a step back and talk about, rather than what we do, how we do it. I want to talk about what makes Saya decentralized and why you can depend on it. So the base component, the basic building block of the Saya network, is a decentralized file contract. So we use a proof of work blockchain to enforce a file contract that we use to essentially arbitrate the relationships between renter and hosts. And so the structure of this file contract is that a renter will go up to a host and say, hey, I have some data. I'd like to store it on the Saya network. Here's some money to pay for it. But in the contract, it also requires the host to take some money out of pocket and put money into that contract. So the host is like, okay, I'll store your data. I see what the reward is for storing the data. To show you that I'm real and that I'm serious about keeping your data safe, I'm going to put some of my own money in. I'm going to risk my own money that if I lose your data, I'm going to lose that money. And so, the contract might have a term of like 12 weeks. At the end of 12 weeks, the host has to provide a proof that says, hey, I still have the data. We use Merkle trees and a probabilistic argument. I won't get into that right now. But essentially, we use cryptography, and the host can cryptographically prove that they still have the data to the blockchain. If the host successfully completes that proof, they get the renter's money and they get their money back. And if the proof is not successful, all of the money actually gets destroyed, which may sound kind of weird, but we don't want to give it back to the renter. So if we give the money back to the renter has a reason to see the host fail. We don't want to see renters, especially like large customers, going and attacking our network so that they get refunds on data that was stored honestly. So there is no reason for the renter to ever want to see a host fail. They're not getting money back. All they're getting is their data's gone. And so we think it's very important for the incentives that we destroy the money as opposed to return it. So that contract forms one relationship between a renter and a host. But the reality of distributed systems and distributed networks is that nothing is reliable. And we embrace this at SIA. We don't expect our hosts to be 100% reliable. In fact, we assume when we give hosts some data, there's a very good chance that they are going to fail, they are going to pay their contract penalty, or they're going to have some downtime. And if we didn't take other steps, this would be problematic for the renter. However, we can use something called Reed-Solomon coding to split the data up. So we take a chunk of data, and we split it up into 30 pieces. Each piece gets encrypted with a separate key. This keeps the host from collaborating, but also protects the user data. So the host never sees what the user's data is. Then we send these 30 pieces out to 30 different hosts. And Reed-Solomon coding is such that as long as you have any 10 of those 30 pieces, and it doesn't matter which 10, you just need 10 of them, you can download the data and you can get your files back. So we have the situation where even if our hosts are only 90% reliable, oh boy, okay. Even if the hosts are only 90% reliable, the user gets to experience 11 nines of uptime on a 10 of 30 scheme. So the user actually expects as many as 3 hosts to be offline at any given time, and has tons of buffer room for rare events where 15 hosts are offline. But as we show, like if you do the math out, you see that at 90% reliability, it's extremely unlikely that you're going to have 15 or 20 hosts go offline at once. So I want to mention 2 more things before I take questions. One is that we use state channels. So I think a lot of people miss the fact that uploading and downloading to the SIA network is instant. So you go through the setup phase, kind of like when you bootstrap into the Lightning Network, you have to take some time, you have to form some opening channels. Once you have the channels, you can spend money anywhere else in the Lightning Network instantly and fully securely. SIA works the same way. You have to take some setup time, but once you've completed the setup, you can upload data, download data instantly, fully securely through state channels. And in the past 30 days, because it's decentralized, we don't have an exact number, but we estimate that about 10 million transactions were performed through state channels on the SIA network. So we believe that this is the most active state channel network in the world today. We're very proud of that. The second thing that is just cool that I think gets missed a lot is that SIA supports video streaming. So if you have a SIA node on your computer, you want to stream movies to VLC, you can open up the streaming dialog. You can type in a SIA API endpoint, and it leads with localhost. So localhost :9980/files/my movie, and then VLC will start playing your movie, downloading it from SIA, which is something that I think is pretty cool. And it's not just video streaming; it's any type of content streaming. So I could talk for about 10 more minutes, or I could open up the floor to questions. So I think I will open the floor to questions.
Hello.
Here, test, yes. Hey, so did you say $1 per terabyte?
Download prices are $1 per terabyte. Storage prices are $2 per terabyte per month.
Okay, and then, so what if you want to start a business and you want to just store huge amounts of, like, almost like a database, and then, but you want to have end customers? Is this a good platform?
So the type of storage that Saya is I think would be normally called warm storage. So if you're storing like a SQL database, that's not going to work because every access to the Saya storage is going to take a minimum of 50 milliseconds. And that's too high to do a database. But if you're doing something like serving web pages, serving video, if a user's downloading files, 50 milliseconds is plenty of fast. And so for many use cases, Saya is appropriate, and then for some hot use cases where you need the computer, like the CPU, on the same premises as the storage, Saya is not going to work because they're going to be distributed.
Okay, cool, thanks.
I actually have a question. So how do you provision on Saya?
What do you mean by provision?
How do you provision the amount of storage space for a user?
Oh, that's a great question. So it is an open marketplace, and it's basically first come, first serve. So hosts join the network, and hosts say, hey, I have this storage available at this price. Then the renters on the network scan the host set, and they evaluate the host, and they're like, this host has, this much storage, this much latency, this price, this geographic location. And so they balance all of that, and then they pick the host that they want. So it's actually the client that does its own provisioning. You form contracts with the host, and then if there's like a competition, if there are like 50 clients formed up with the same host, the host will give storage on a first come, first serve basis. And so once the host is full, nobody else can upload to the host. But the money that you put into the state channel has not been locked into the contract. So you get that back. So if you never actually got to utilize the host, you just go on, make a contract with another host, and you'll get all your money back.
You guys run on your own blockchain, is that right?
That's correct.
How do you think about interoperability with other crypto systems?
Yeah, so we believe that the monolithic blockchain model is not a sustainable model or a scalable model, and I think this is most present whenever something really exciting happens in the Ethereum community. One was the status ICO, everything ground to a halt, and then another one was CryptoKitties. Everything else ground. If it wasn't CryptoKitties, it just wasn't happening. And when everything was grinding to a halt on Ethereum, nothing was grinding to a halt on Saya. We just kept going, and I think that is very important. If Saya gets really exciting, it only impacts the throughput of Saya usage. It doesn't impact other applications. So interoperability would come through the Lightning Network or through state channel networks. We believe that many types of smart contracts can be extended into Lightning-style state channel networks. And I think that that's going to be very big in the next 5 to 10 years. And so you'd have a lot of cross-chain, every chain with its own currency, but all interoperating. One more question?
I had a quick question. With the Reed-Solomon, does the client already support Reed-Solomon encoding, like to distribute it across different hosts, or is that transparent, or how does that work?
Yeah, so the client has a Reed-Solomon library, and this has been true since 2015. So it's already there.
I can ask another question.
Okay.
So just real quick, what has been the balance of supply side versus demand side over Saya's life, and are you seeing a shift to more demand than you've had in the past?
We are. So we spent most of the early life of the network at 1% utilization. So we had 100 times as much supply as demand. And then we spent most of the midlife of the network at 2% utilization. And right now, we've wiggled all the way up to 7% utilization. So it's getting better, but it continues to be very, very supply dominated on the Saya network. And that's one of the reasons prices are so attractive.
Thank you.
Can everybody give David a round of applause? Thank you so much, David.